We're given a neat looking curve, y equals x squared minus 2 over x squared minus 4, x not equal to plus or minus 2. Told that it crosses the y-axis at u, so that's here, and to write down the coordinates. So at u, x equals 0, and y is going to equal 0 squared minus 2, so minus 2, over 0 squared minus 4, which is going to give us a half. Therefore, the coordinates will be u, 0, a half. Next up, we're told that the point P with x coordinates a, but a is not equal to 0, and it's not going to equal 2 or minus 2 either, lies on C, and we're asked to show the normal at P, to see at P cuts the y-axis at this point. Okay, let's think a little bit about the normal. So let's say let's say A is over here. Then I could draw a tangent to this, just a line that glances off. And then the normal would be the line that's perpendicular. So it's this that I'm then interested in finding. But of course, we're working in terms of A, so our answer is going to be in terms of A. Well, let's work out what dy by dx is, because that's how we're going to get the gradient of the normal. For this, we can use the quotient rule. I'm going to call this u, this v. So u dash is 2x, v dash is also 2x. Quotient rule says that dy by dx is u dash v minus uv dash all over v squared. So 2x times x squared minus 4 minus 2x times x squared minus 2 all over v squared, which is x squared minus 4 squared. I can simplify this. I'm going to get 2x cubed minus 8x plus 2x cubed plus 4x. I could have factorized out the 2x, but I've just done it this way instead. The 2x cubes are going to cancel. Sorry, but that should have been a minus. And then I've got minus 4x over x squared minus 4 squared. Okay, so at x equals a, dy by dx is then going to equal minus 4a over a squared minus 4 squared. And this is the tangent gradient, as well as the gradient of the curve at that point. So the normal gradient is the negative reciprocal. So the tangent gradient was, say, a half, the normal gradient would be minus 2. They multiply to give minus 1 overall. So I just flip it round, a squared minus 4 all squared over 4a. I get rid of the negative as well. So the normal equation if we use y minus y1, well, y1 is going to be what we get when we substitute x equals a into here. So it would be y minus a squared minus 2 over a squared minus 4. And that is going to equal my gradient, a squared minus 4 all squared over 4a times x minus a. And then we're interested in where it cuts the y-axis. So when x is equal to 0, y is going to equal a squared minus 2 over a squared minus 4, because I can add it onto both sides. And then I'm going to be minusing a times, so that's this bit here, a times a squared minus 4 squared over 4a The a's are going to cancel, and that's going to give me my result. So I'm just going to say result follows. Okay, moving on. All right, so 10 marker at the end. So we're told that the circle E with center on the y-axis touches all three branches of C. So here's one I did earlier. It's going to look a little bit like this. Okay, I've just made sure. I mean, and look, you're just going to have to draw a sketch if you're doing this in the real thing, but it's, yeah, we're going to get it touching in these three places. And then we're asked to show that this is true. So let me identify some points on the circle. First up, we found at the very first part of the question that this is equal to a half. And then I've got the center of my circle. Let's put it here. And I know where it touches the point on the curve, I'm going to get the radius. And I can draw a line going across and up to create a triangle. Now I can say that this coordinate here is going to be P. There's nothing wrong with me calling that. So P, and then it's going to be A, then A squared minus 2 over A squared minus 4. Remember what we did in the previous part? We said that all normals have, well, we can find the y-intercept of all the normals. So a circle where it meets a curve, actually, we can draw a tangent to it because they're just touching. So we could draw a tangent in between. Now all have the same gradient at that particular point. And if I then draw the normal, then it's gonna go through the center of the circle. That's a circle theorem actually, that the tangent and the normal no, sorry, that there'll be 90 degrees between the radius and the tangent, and the radius is a normal. Okay, why is all this useful? Because actually this height, which I'm now going to call k, that k is what we found in the previous part. So it was this a squared minus 2 over a squared minus 4 minus a squared minus 4 squared over 4, which means the radius is going to be k minus a half, or a squared minus 2 over a squared minus 4 minus a squared minus 4 squared over 4 minus a half. Okay, so what I have is one equation for the radius. But there's another way to get it, which comes with this triangle up here, because I can actually now apply Pythagoras' theorem. I know that this is A, and I've got my point P, so I can also work out the height of this triangle. So the height of this triangle is actually going to be this thing minus this thing here, because I'm going up this amount, but I want to subtract k from it. So I'm just going to draw this triangle out below. Got the radius, I've got A, and then I've got a squared minus 2 over a squared minus 4, and I am minusing my k. So a squared minus 2 over a squared minus 4 minus a squared minus 4 squared over 4. And And these two are actually going to cancel. So I'm just going to be left as my height, a squared minus 4 squared over 4. Okay, I just kind of want to backtrack and go over some aspects of this again. Let's actually just return to the original question. We worked out where u was, that was okay. We differentiated and found the gradient of the tangent and then the normal, and found out that the normal to C at P, at x equals a, will cut the y-axis at this point. Okay, that was a useful result. And now we're considering the circle that touches the curve in all three places at the bottom, left, and right. I've talked about the fact that if we drew a tangent at this point, they'll all have the same gradient, and then we can draw the normal, and that will go through the center. Okay, that piece of information is really important because it goes through the center, and we've just shown that the normal cuts the y-axis at this y position here. Then we've actually got this value k, and we've got the radius because it's going to be k minus a half. Really useful. We can also then get the radius by drawing a little triangle and using Pythagoras' theorem. So because the point is when x equals a, I've got my y coordinate here that I've circled. I've got my x coordinate is a. So I'm going along a, and then I'm going up by this amount. But if I look at the little triangle, I need to then subtract k from it. So I've got my a squared minus 2 over a squared minus 4, and I'm minusing k. It all cancels out quite nicely, and we're left with this. Now I can use Pythagoras' theorem and write down that r squared is going to be a squared plus a squared minus 4 to the power of 4 all over 16. So that is a second result for r squared. So now I can take my other result and I can square it and set the two equal to each other. So therefore, a squared plus a squared minus 4 to the power of 4 over 16 is going to equal a squared minus 2 over a squared minus 4 minus a squared minus 4 squared over 4 minus a half all squared. So this one has come from the knowing where the normal hits the curve, hits the y-axis, sorry, and the one on the left has come from applying Pythagoras' theorem. Remember, this is what we're trying to get to. So I've actually got the right-hand side because it's my left-hand side. I just need to manipulate my right-hand side. And what I can do is I need to sort that half out. So I can write it, put it over a common denominator of it can be a squared minus 4 over 2 a squared minus 4. That's still equal to a half. And then I can bring a 2 in here. So a squared plus a squared minus 4 to the 4 over 16 is going to equal, I need that big bracket because I'm squaring the whole thing, 2a squared minus 4. I've just expanded this out. And then I'm going to minus this term. So I'll get minus a squared plus 4, because there'll be a bracket there. Then it'll be all over 2a squared minus 4. So I brought these two terms together. And then don't forget I need to minus a squared minus 4 squared over 4. And then finally I have to square the whole thing. The minus 4 and the plus 4 cancel. And you can then see I'm going to get a squared in the numerator here. And the result's going to follow. Nice. Right, C part 2, hence show that this is true. So we've got this really complicated equation, but it's going to massively simplify. Okay, let's take the right-hand side and expand the bracket. We can't really avoid doing that. So I'm going to get a to the 4 over 4 a squared minus 4 squared when I times this term by itself, plus a squared minus 4 to the 4 over 16 when I times this term by itself. And then it's going to be minus 2 lots of a squared over 2 a squared minus 4 times a squared minus 4 squared over 4 when I do my cross multiplying terms, but I do it twice. And that is going to equal a squared plus, I'm running out of room, a squared minus 4 over 16. Okay, well, the first thing we see is that actually this and this cancel out, so that's brilliant. And actually, okay, this cancels out with the squared. Okay, and the 2 and the 4 partially cancel as well. So let's just bring it back together. Do the next step. So then I'm minusing so I'm just trying to what did I do? Oh yeah, so I'm minusing a squared minus 4 all over 4 because I've still got this 2 and I've still got this 2 and that's going to equal a squared. Right, it's a fractional equation, so let me multiply through by this thing here. So a to the 4 minus a squared minus 4 over 4 times by 4 a squared minus 4 squared is going to equal 4 a squared minus 4 squared. These 4's cancel. A to the 4 minus a squared minus 4 cubed equals 4 a squared minus 4 squared. You just got to trust that I've not made a mistake. I'm going to leave the a to the 4 on the left, and then on the right, I'm gonna add this to, actually I'm not gonna do too much in one go. So this plus this is, now I can see there's some common terms. I can actually take out a common factor of a squared and of a squared minus 4 squared. Then I'm left with 4 plus a squared minus 4, in fact. So if you expand this back out, you'll get, yeah, you will get back to that term. Okay, that didn't look like it was going to happen, but it's suddenly cancelling out really nicely. So the 4 and the minus 4 cancel. And then I can also, I can write it as a to the 4, a squared minus 4 squared. And the a to the 4's are going to cancel. This becomes 1, which means that a squared minus 4 squared equals 1, which is what we wanted. Okay, that is fiddly. Do you know what? I said that that part was harder. I don't know. I think it's easy to make a mistake here. At least just to show that question so we know we are correct if we get to here. Right, we're nearly there. So where are we? All the way back here. Part 3 says find the center and the radius of E. Okay, so let's work out what A is equal to. Now we can take a square root, so x squared minus 4 is going to equal plus or minus 1. And therefore A squared is going to equal this minus 1, we're going to get 3. This 1, we're going to get 5. Therefore A is going to equal plus or minus the square root of 3, or plus or minus the square root of 5. Okay, 4 different answers for A. Let's just look at the graph. Now remember, x equals 2 was an asymptote, so A is going to have to be greater than 2 because it's going to touch beyond, the curve doesn't actually go less than 2 on the right. So I can immediately reject these ones here. They're solutions to the equation, but they're not solutions to the actual problem. Reject um, since curve meets circle to the right of x equals 2 and left of x equals minus 2. The plus and minus for the other ones are okay because it's going to correspond to here with the root 5 and to here with the minus root 5. I have also got 0, and we sort of lost that solution when we divided by it here. So a equal to, but remember we said that a was not equal to 0, didn't we? I can't remember. Yeah, a was not equal to 0 because of the normal property, but it does still touch at that point. That's not part of it anyway. Let's not worry about that. So now we've got A, we can work out the center and the radius. Remember, this, what was the radius? I've forgotten. Okay, this was the radius, k minus 2, and the center was actually 0k. So let's work out what k is. That is a good idea. And to get the radius, we can just minus a half from it. Sorted. So k is going to equal 5 minus 2 over 5 minus 4 minus 5 minus 4 squared over 4. This gives 3 minus a quarter, which is going to be 12 over 4 minus 1 over 4, so 11 over 4. And hence the center is going to be 0, 11 over 4. The radius, remember, is equal to k minus a half. So 11 over 4 minus 2 over 4 gives 9 over 4. Right, that I think is an awkward problem. I don't know how long that took me to go through it, but I've written a lot. I hope that makes sense. Well done on your efforts on it.